Plywood is one of the most essential materials in construction, furniture making, cabinetry, flooring, and countless other applications. It's a durable, versatile, and cost-effective material that is so deeply woven into the fabric of the modern world that we often overlook its production. But have you ever wondered about how plywood is mass-produced in factories? How do raw logs turn into the final sheets that are used for everything from furniture to skyscrapers? This documentary takes you behind the scenes of plywood production, revealing each step in the process and the complex technology that makes plywood one of the most used materials in construction. The story of plywood starts with trees. However, not just any trees will do. Plywood is produced from both softwood and hardwood species of trees. But softwoods are more commonly used in mass production. Softwoods like pine, fir, spruce, and cedar are particularly favored for their strength, lightweight, and ease of working with. They also grow more rapidly than hardwood trees, making them more sustainable and economical. Hardwoods such as birch, oak, or maple are often used for premium plywood grades, such as furniture-grade plywood, or plywood for applications requiring a higher aesthetic standard. These hardwoods tend to be denser, more durable, and offer an enhanced visual appeal, making them ideal for decorative or high-end plywood used in cabinetry and furniture. However, the key to any good plywood starts in the forest. Sustainable sourcing is at the heart of modern timber harvesting practices. Companies involved in plywood production are increasingly working with certified sustainable forestry operations that adhere to industry standards like the Forest Stewardship Council, FSC. These certifications ensure that trees are harvested in ways that protect ecosystems, preserve biodiversity, and maintain the health of forests for future generations. Once the trees are selected and marked for harvesting, they are felled. The trees, which can be up to 100 feet tall and several feet in diameter, are then transported to the mills. This transportation process involves specialized machinery and transportation vehicles capable of moving massive logs safely and efficiently. Upon arrival at the mill, the logs are ready for the next stage in the production process, debarking. The first step after the logs arrive at the factory is debarking. The outer bark of a tree is rough and full of contaminants, which can interfere with the production of high-quality plywood. To remove the bark, the logs are placed into large machines called debarkers. These machines rotate the logs and scrape off the bark, ensuring that only the smooth, clean wood beneath remains. Debarking is not only about aesthetics. The presence of bark or any other foreign materials can negatively impact the gluing and bonding process during the veneer layering stages. The debarking process also prevents the buildup of contaminants on the wood that could lead to imperfections in the finished plywood. Interestingly, the bark is not discarded, but is often repurposed. It is commonly shredded and used as mulch, fuel for the mill's energy needs, or even compost for agricultural use. This is a great example of the factory's commitment to sustainability, where almost every part of the tree is used in one way or another. Once the bark is removed, the logs are inspected to ensure they are free of defects and ready for the next phase of processing, peeling. Now the logs are ready to be transformed into thin sheets of wood, also known as veneers. The process of peeling the logs into veneers begins with the use of a rotary lathe. In this machine, the log is mounted horizontally, and the rotary lathe spins the log at high speeds, while a sharp blade peels it into continuous sheets of veneer. Veneers are the thin layers that form the core of the plywood. The thickness of each veneer is crucial. Most veneers used in plywood production are between 1/16 and 1/8 inch thick, but this can vary depending on the end use of the plywood. For higher quality plywood, the veneer is thinner, while thicker veneers are used for heavy-duty plywood designed to carry large loads or endure extreme conditions. The rotary peeling method is incredibly efficient. However, maintaining consistency in the veneer thickness is a challenge. The machine has to be calibrated carefully, as any variation in thickness can lead to weak spots in the plywood. The resulting veneer is long and ribbon-like, often extending several feet in length. This continuous peel of veneer is then cut into manageable sections. After the veneer is peeled, it is immediately dried in a large oven or veneer dryer. The drying process is essential to remove excess moisture from the wood. If the moisture content in the veneer is too high, it could affect the bonding process in the later stages of production, leading to potential structural weaknesses in the final plywood. The veneer is dried at high temperatures until it reaches a moisture content that is ideal for bonding. Once the veneers have been dried, they undergo a rigorous sorting and grading process. Not all veneers are created equal. Veneers are inspected for imperfections such as cracks, warping, or discoloration. In this step, workers or automated machines inspect each veneer sheet, discarding any that have defects that would affect the plywood's integrity. These defective pieces might be used for lower-grade plywood or discarded altogether. Veneers are graded based on their appearance, structural integrity, and the specific application they will be used for. High-grade veneers are perfect for furniture, cabinetry, and decorative plywood, while lower-grade veneers are used for plywood that will be covered or hidden in its final application. High-grade veneers are clear of knots, cracks, and other visual imperfections. Lower-grade sheets may have minor defects, but their strength is still sufficient for construction purposes. In some mills, the veneer is also treated at this stage. Treatments such as flame-retardant chemicals or moisture-resistant coatings are applied to enhance the plywood's properties. This is particularly useful for plywood intended for special environments, such as marine-grade plywood, which is used in boats, or plywood used in high-moisture areas like bathrooms. Once sorted, graded, and treated, the veneers are cut to the required dimensions, typically standardized for plywood sheets, such as 4 feet by 8 feet, though custom sizes can also be ordered for specific applications. With the veneers sorted and prepared, it's time to start building the plywood's layers. The key to plywood's strength is its multi-layered construction. The process begins by stacking the veneer sheets in alternating grain directions. The direction of the wood grain in each layer is crucial, as it prevents the plywood from warping or bending. The alternating grain direction gives the plywood its strength, ensuring that it can handle both compression and tension forces. The adhesive used to bond the veneers together plays a crucial role in this stage. The adhesive is typically a resin-based glue, often phenolic or urea formaldehyde. These adhesives are applied to each veneer layer, ensuring that the layers will bond securely. The glue is spread evenly across the entire surface of the veneer, ensuring complete adhesion to the next layer. Once the glue is applied, the layers of veneer are carefully stacked. The process requires precision to ensure that each layer is perfectly aligned and that no air bubbles or gaps are left between the veneers. The more layers used, the stronger the plywood will be. Typically, 3 to 5 layers of veneer are used for standard plywood, but thicker plywood, like that used for heavy-duty construction, may have more layers. After the layers are stacked and the glue has been applied, the plywood is ready to move on to the pressing stage. The pressing stage is perhaps the most critical in plywood production. The stacked veneers, which are now glued together, are placed in a hydraulic press. The press applies immense pressure to bond the layers together, while heating elements cure the adhesive, solidifying the bond between the layers. The pressure applied in this step is immense, thousands of pounds per square inch, to ensure that the adhesive spreads evenly and that the layers bond securely. The heat helps to speed up the curing process, ensuring that the adhesive bonds quickly and securely. The time and pressure applied in the press are critical to achieving the right bond. If the pressure is too high, the plywood may become warped. If it's too low, the bond between the layers may not be strong enough. In some cases, a continuous press is used, where large sheets of plywood pass through the press without interruption. In other factories, batch presses are used, where individual sheets of plywood are pressed one at a time. The choice of press depends on the production volume and the type of plywood being made. Once the plywood is pressed, it is allowed to cool down. Cooling ensures that the adhesive has fully solidified and that the plywood retains its shape and strength. The cooling process can take several hours, and the plywood is carefully monitored to ensure it cools evenly. After the plywood has cooled, it is ready for the next stage. Cutting. The plywood sheets are moved to large cutting machines, where they are trimmed to the required dimensions. Standard plywood sheets are usually 4 feet by 8 feet, but custom sizes are often produced based on the customer's needs. After cutting, the plywood moves to the sanding stage. Sanding is crucial to ensure that the plywood surface is smooth and free from rough edges. This step is especially important for plywood that will be used in furniture or cabinetry, where a smooth, flawless surface is required. The The sanding process can be done with either handheld tools or large industrial sanding machines. These machines use abrasive materials, such as sandpaper, to smooth out the surface of the plywood. The sanding process also removes any residual glue that may have seeped out during the pressing stage, ensuring that the surface of the plywood is clean and ready for any further treatments or finishes. For high-quality plywood, multiple sanding passes may be required to achieve a perfectly smooth finish. This is particularly important for decorative plywood that will be painted or stained. Once the plywood has been cut and sanded, it moves to the quality control stage. Here, each sheet of plywood is carefully examined to ensure that it meets the required standards. Inspectors check for defects such as warping, cracks, and imperfections that could compromise the structural integrity of the plywood. The quality control process is essential to ensuring that the plywood meets the necessary strength and durability standards. For certain types of plywood, such as marine-grade plywood, additional tests may be conducted to ensure that the product is water-resistant and capable of handling the harsh conditions it will be exposed to. Quality control inspections are also conducted to verify the thickness and consistency of each sheet. Once the plywood has passed inspection, it is ready to be packaged and shipped to its destination. After passing the quality control check, the plywood is packaged for shipment. The sheets are carefully stacked and wrapped to protect them during transportation. Depending on the factory, the plywood may be wrapped in plastic, covered with cardboard, or placed in wooden crates to prevent damage during transit. Plywood is used in a variety of industries and applications, so it's essential that the material reaches its destination safely. Whether the plywood is being shipped to a construction site, a furniture manufacturer, or a retailer, the packaging ensures that it arrives in perfect condition. The plywood is then loaded onto trucks, trains, or ships for distribution to retailers, contractors, or other customers around the world. Given the global demand for plywood, it is shipped across continents, reaching industries in North America, Europe, Asia, and beyond. The plywood industry has grown significantly over the years. With the ever-increasing demand for plywood in construction, furniture manufacturing, and a variety of other applications, the industry continues to thrive. The versatility, strength, and cost-effectiveness of plywood make it a staple in modern construction. And as populations grow and more infrastructure is built, the demand for plywood will only continue to rise. As technology improves, the plywood production process has become more efficient, and new techniques are being developed to improve the material's performance. For example, advances in adhesive technology have allowed for stronger, more durable plywood that is also more environmentally friendly. New pressing techniques have led to faster production times, and more precise cutting machines have made plywood sheets more uniform in size and quality. As the global push for sustainability continues, the plywood industry is also evolving to meet environmental demands. Manufacturers are adopting greener practices, such as using recycled wood, reducing waste, and developing more eco-friendly adhesives. Sustainable forestry practices are being improved to minimize the environmental impact of logging, and certification programs like FSC are ensuring that the wood used in plywood production comes from responsibly managed forests. Looking to the future, plywood may become even more sustainable and environmentally friendly, with manufacturers exploring alternative materials and methods that reduce their carbon footprint. The increasing demand for eco-friendly products means that the plywood industry will need to continue innovating to meet these new challenges. Plywood has come a long way since its inception. From humble beginnings as a practical solution to wood shortages, it has become one of the most vital materials used in construction and design. The advanced machinery, carefully regulated processes, and cutting-edge technology involved in plywood production make it a product of both art and engineering. As we look toward the future, plywood will continue to evolve, meeting the needs of industries worldwide while maintaining its status as one of the most versatile and reliable building materials available. From raw timber to finished sheets, the process of making plywood is a fascinating journey that showcases the power of innovation, sustainability, and craftsmanship. Next time you see a sheet of plywood, remember the incredible journey it's been on, from the forests to the factories, and eventually to the countless applications it supports in our daily lives. It's not just a material, It's a testament to human ingenuity and the endless possibilities that await when creativity and technology collide.